record on this computer. Okay, here we go. All right, so we are going, so last week I showed you guys how to solve systems of equations by graphing, right? Or 2 weeks ago, I guess. And so now I need to show you how to solve systems of equations by elimination. So elimination is easiest when the equations are in standard form. So y'all know the difference between a standard form and slope-intercept form, right? So slope-intercept form is when the equation is solved for y. And then these two equations right here are in standard form. So when x and y are on the same side of the equal sign together, that's considered standard form. All right, so you guys are going to like this when I show you how easy this is. So instead of graphing both of these lines to figure out where they intersect, we can use what we call elimination. All righty. So all I'm going to do is I'm going to put a plus symbol right here and do this, and then I'm going to combine like terms. All right, so I have 3x plus 3x, and I get 6x. And then see what happens here. Negative 3y combined with positive 3y is 0. So basically, our y's are eliminated. That's why we call it elimination. We want to eliminate one of the variables. And the way this equation is written, these equations, the y's cancel each other out. So we combined our x's, and the negative 15 combined with negative 3 is negative 18. There's no y, so our only choice is to solve for x. So we're going to do the opposite of times 6. We're going to divide both sides by 6. So x is equal to negative 3. Wasn't that easy? Nice, right? Well, so all of the solutions for systems has to have an x and a y. So now we're going to take our solution of x. So we know that half of our answer is x is negative 3. Now we're going to plug in negative 3 for x in either of our equations. It doesn't matter which one we use. I'm just going to use the top one. I'm going to plug in negative 3 for x to figure out what y is. Okay, so 3 times negative 3 is negative 9 minus 3y equals negative 15. So now I'm going to add 9 to both sides. And I get negative 3y is equal to negative 6. And then when I divide both sides by negative 3, I see that y is equal to 2. So now I have my x value, I have my y value, and that is the solution right there. And if I really wanted to be smart and double check, I could take my solution, negative 3, 2, I could plug it into either one of these equations to make sure I get a true statement. For example, 3 times negative 3 is negative 9. 3 plus 3 times 2, 3 times 2 is 6. And I know for sure that that equals negative 3. So I know my answer is correct. Okay. Hi, Helena. You might have to go back and watch this part of the video. Okay. I know you guys were taking a CBA. All right. So that's the first example. All right. So when one of your x's or y's will cancel each other out simply by the way the equation is written, it's really simple that way. But sometimes though, you're going to have to multiply by a digit in order to make one of your variables cancel. Okay, so I think this is the wrong video. This is the wrong warm-up. Hold on. I wanted to give y'all some more easy problems before we jumped right into the harder ones. Sorry, let me look for a second. Elimination. Okay. I'm going to do a couple more easy problems before I give you the harder ones, okay? All right, so can y'all see my screen here? Do y'all see my slideshow now? Okay. All right, so now if you'll notice this equation, the way it's written, the x's are going to eliminate because there's a positive x and a negative x. You see that? All right, so they're both written in standard form. So Helena, I told them earlier when it's written in, when your equations are both written in standard form, elimination is the best way to solve a system of equations. So all I'm going to do is combine like terms. So x combined with negative x is 0. So my x's cancel. And then I have 1y plus 3y is 4y. And now 6 combined with negative 2 is positive 4. And now to solve for y, I'm going to divide both sides by 4. And y is equal to 1. All right, somebody has a question. Let me look. I just see the review number 1, and it's the one that you guys just did. Y'all didn't see the problem I just did? You see the old one? Hold on, let me reshare. Is this a different problem now, Helena? Ah, all right. Messing this stuff all up, aren't I? All right, let's try this again. All right, so the way this equation is written, if you'll notice, the two x's are opposites. In other words, the x's will eliminate each other, okay? So x combined with negative x, this goes away. So now we have 1y plus 3y is 4y. 6 combined with negative 2 is 4. And then to solve for y, I'm going to divide both sides by 4. And my y value is equal to 4 divided by 4 is 1. So we don't know our x value, but we know our y value is 1. In order to get the x value, I'm going to take either one of my equations and I'm going to plug in 1 for y. So I'm just going to plug it into the top one. So my top equation says x plus y, and y is 1, equals 6. And now to solve for x, I'm going to subtract 1 from both sides, and x is 5. So my solution is 5, 1. And I just solved this system of equations by eliminating my x's. Any questions about that one? All right, I am going to kind of go a little fast, but remember, I am recording this and I will send this recording to all of you, okay? All right, so let's try number 1 together, and then I want all of you guys to try number 2 on your own. Okie dokie. All right, so what you're looking for is, for the variables, you want one to be positive and one to be negative. Hopefully they have the same coefficient, and on both of these problems they do. So sometimes the y's will cancel and sometimes the x's. It doesn't matter which one you cancel out. All right, so on this one, I noticed that the x's are going to cancel each other out because I have a positive 2x and a negative 2x. So those, when I combine like terms, give me a 0. And now I have negative 3y combined with negative 4y. So negative 3 combined with negative 4 is negative 7. And then I have 4 combined with negative 4. 4 combined with negative 4 is 0. And now I need to solve for y by, what's the opposite of multiplying by negative 7? I'm going to divide both sides by negative 7. And what's 0 divided by negative 7? Do I get a real answer? Yep, I do get a real answer. I get 0. And if you're not sure, put it in your calculator. If your denominator is 0, it'll be no solution. But if the numerator is 0, that's a real answer. All right, so we know our y value is 0. Now we need our x value by plugging in 0 for y. So I'm going to take the top equation. If I plugged in negative 3 times 0, negative 3 times 0 is 0, right? So I'm left with negative 2 is equal to 4. When I divide both sides by 2, I get 2. So my answer is 2, 0. 2, 0. All righty. All right, I want the 3 of you to please try number 2 and send me your answers. And remember, I need a whole ordered pair. I need basically two numbers. I need an x value and a y value. righty, I got one answer. Oops. I got one answer. It looks great. Allie, are you doing anything? What are you doing, Allie? You're spacing out on me, girl. All right, so Helena, sorry, thinks the answer is 4, -1. I think she's right. All right, so our x's eliminated each other. So 2y plus 1y is 3y. 4 combined with -7 is -3. So if we divide both sides by -3, y is -1. So the y value is correct. Thank you. So now I'm going to take my first equation and plug in -1 for y. So x plus 2 times -1 equals 4. So we have x minus 2 equals 4. Uh-oh. Did I do that right? So then we're going to add 2 to both sides. And then x equals 6. That's what I got. Does anyone agree with me? Helena does not agree with me. Helena, who's right, you or me? I don't know, she said. All right, well, let's see if we plug in -6 plus -1. So my solution works on the second one. And then on the top one, 6 plus 2 times -1 is -2. Yep. So I'm going to have to go with 6 -1. So see if you can find the mistake. How we doing, Naomi? How we doing, Allie? Good. All right, can we move on, ladies? I'm sorry to be rushing you. All right, so now these two is going to be, one of them is going to be no solution and the other one's going to be an infinite number of solutions. All right, so let's look at the difference on these two. So if you look at number 3, I notice immediately that my x's are going to eliminate one another, so I don't have to do anything to it but combine like terms. So 3x combined with a -3x is 0, right? Well, it just so happens that my y's will eliminate also because I have a -2y combined with a +2y, which is also 0. So the only thing we have left on the left side of our equation or our equal sign is 0. Well, on the right side of the equal sign, I see 17 combined with -16, which is +1. So look what I wrote. I wrote 0 is equal to 1. Is that correct? If someone owes you $1 and they go, okay, I have $0, we're paid up. Are you going to be, okay, that's cool? Well, no, because those are not equal. Okay, so if you come up with an incorrect statement, that means there is no solution, which basically means you're going to have 2 parallel lines, right? No solution. If you come up with an incorrect statement, that means there's no solution. All right, but let's look at number 4. And if y'all need my notes, I will send those to you as well. All right, so number 4, once again, our x's cancel each other out. -4 combined with +4 is 0. And then I have a +y combined with a -y. That's also 0. So on the left side of the equal sign, I only have 0. But then look what happens on the right side of the equal sign. -10 plus 10 is also 0. So my final statement on this one is 0 equals 0. Is that true? That is true. So if you end up eliminating all of your variables and you end up with a true statement, that means that you have an infinite number of solutions, infinitely many solutions. So do you guys see the difference in these two answers? So you might want to make a note which one is no solution and which one is an infinite number of solutions. Do you have any questions? We're good? Okay. All right, moving on. I want the three of you to pick one of these two problems to do, please. I want you to do the first one or the second one, please. Ready, set, go. Hi, Ella. Welcome to class. I've recorded this lesson so far, so you're going to have to probably go back and watch what we've already done, okay? And right now, the ladies here are trying one of these two problems, whichever one. I am not muted. Allie, can you hear me?
I hear you.
She thinks I'm muted. Can you hear me, Ella? Ella? Oh, now you can hear me. All right, so basically what I said was they're trying one of these two problems. I have recorded the class up until now, so you might have to go back and watch it when we're done, okay? All right, because we're so short with time, I'm going to ahead and you guys keep working on them. If you started one, I'm going to go ahead and start solving them as well. All right, so Ella, what I'm showing you guys today is called elimination. So what you're looking for is one of the variables to have opposite coefficients. Okay, so the opposite of 5 would be -5. The opposite of 1 would be -1. So in this first example, hopefully you notice that the y's have opposite coefficients. So one is a -1 and one's a +1. So when your equations are written in standard form, like these are, the easiest way to solve the system of equations is with what we call elimination. So all I'm going to do is combine like terms. So 3x plus 2x is 5x. My y's will cancel each other out. -y plus y is 0. That's why we call it elimination. And then 7 plus 8 is 15. So to solve for x, I'm going to divide both sides by 5. And I see that x is equal to 3. Isn't that easy? This is the best way to solve. All right, so now to solve for y, we're going to plug in 3 for x into either one of the equations. It doesn't matter. I'm just going to pick the second one. So I'm going to plug in 2 times x, which is 3, plus y equals 8. 2 times 3 is 6. And to solve for y, I'm going to subtract 6 from both sides, and I see that y is equal to 2. So my solution to this system of equations is 3, 2. So if I graph both of these lines, I know they would intersect at 3, 2. Okie dokie. On the second example, once again, the y's will eliminate each other. They have opposite coefficients. Sometimes it's the x's, sometimes it's the y's. It doesn't matter. You just always want to go with it, whatever's easiest. So the way this one's written, the y's will eliminate each other. So now we're going to combine 2x plus 1x, which is 3x. Positive 3y combined with negative 3y is gone. And then 12 plus 18 is 30. I'm going to divide both sides by 3. And that tells me that x is equal to 10. All right, and then to solve for y, I'm going to plug in Doesn't matter. Either one of them doesn't matter. So if x is 10, I'm going to use the second one. X is 10 minus 3y equals 18. I'm going to subtract 10 from both sides. Excuse me. I get negative 3y equals 18 minus 10 is 8. I'm going to divide both sides by negative 3. And y is equal to negative 8/3, which of course we don't like fractions, but sometimes you do get a fraction as an answer. So my solution is 10 negative 8/3. That is my solution. All right, what questions do we have? No questions? Okay, so of course it's got to get a little harder sometimes. So it says, what if there is not a set of opposites to cancel out? Well, then you are going to have to create opposites. So since I don't see opposite coefficients, I'm going to pick out, hopefully they have one of the variables have the same coefficient, which of course they both have ones. The x's have ones. So what's the only thing that will cancel out a positive x? Yeah, a negative x, exactly right. The only thing that will cancel out a positive x is a negative x. So that means I have to change one of the equations so that my x is going to be negative. It doesn't matter which one I change, but whatever you multiply x by to make it negative x, you have to multiply the whole equation by the same digit. So the only thing I can multiply x by to make it equal negative x is negative 1, right? So I'm going to rewrite my top equation, x plus 2y equals 0. On my second equation, I'm going to distribute the negative 1 to every single term. Negative 1 times x is negative x. Negative 1 times y is negative y. And negative 1 times 2 is negative 2. So now I combine like terms. X combined with negative x goes away. 2y minus y is 1y. And 0 combined with negative 2 is negative 2. So my y value is negative 2. And to find my y value, x value, I'm going to plug in negative 2 to either one of these equations. It doesn't matter. I'll just use the top one. X plus, well, 2 times negative 2. 2 times negative 2 is minus 4. And then to solve for x, I'm going to add 4 to both sides. So the value of x is actually 4. And I have just solved. Still using elimination, but I had to do one extra step. Any questions? Okay. All right, I'm going to move on unless someone says, wait, please. All right, so on these, since we don't have opposite pairs, we're looking for at least the same coefficient. All right, so number 17, I have the same coefficient, 9x and 9x. And on 18, the y's have the same coefficient, right? So if they're both positive, I have to make one negative. And like on 18, these are both negative, which means I need to make one of them positive, right? So it doesn't matter which one you change, doesn't matter. I know that the only thing that can cancel out a 9x is a negative 9x. So once again, I'm going to multiply every single term by negative 1. So I'm going to bring down my first equation. My second equation becomes negative 1 times 9x is negative 9x. Negative 1 times 5y is negative 5y. And 17 times negative 17. I mean, 17 is, you know what I mean. All right, what happens to my x's? They're gone, right? Then I have 1y combined with negative 5y. What's 1 minus 5? Negative 4y. 25 combined with negative 17 is 8. And then I'm going to divide both sides by -4. So my y value is -2. And now I'm going to plug in -2 into my top equation to figure out what y is. I'm sorry, x is. Whoops, it's not -2y, it's just -2. Equals 25. So I'm going to add 2 to both sides. And when I divide by 9, I get x is 3. So my answer is 3, -2. All right, I want you guys to try number 18, please. All right. I'm sorry to rush you, ladies. I got -3, 1. It looks like Naomi got -3, 1. How did the rest of you do? Yay, that's what Ella got too. Allie, Helena? Yeah? Y'all good? Okay. Awesome. Okay. So I think on your test, it doesn't get harder than that. However, on your assignment tomorrow, I think you do have to multiply by a different number. All right, so I'm going to bring up the other PowerPoint real quick just to show you. Let's see. Sorry. Let me find the other questions we started with. There it is. Give me 1 second. I have too many windows open, you guys. Okay. So Michael Meadows is trying to join. Let me let him in. All right, so let me go through this one. Let me show you one more example, guys. Okay. We started with that one. All right, so occasionally, hi, Michael. I've recorded this whole thing, Michael, so you can go back and watch it, all right? All right, so if you'll notice on this problem, there are not any that's already written that have the opposite coefficients or even the same coefficient, right? So sometimes you have to multiply by a number other than -1. So for example, we do already have a negative coefficients, but they're not the same number, just opposite digits. I think y'all know what I'm trying to say. So I'm looking at the y's. This is a +1 and this is a -3. Okay, so at least I already have opposite coefficients. I just don't have the same digit. So what's the only thing I would be able to use to eliminate a -3y? What's the only thing that would eliminate a -3y? Well, of course, that would be a +3y, right? So can I do anything to +1y to make it equal +3y? Yep, I can multiply it by 3, right? So that's what I'm going to do. I'm going to multiply the whole top equation by 3 so I can still eliminate the y's. So I'm not changing the bottom one. Oh, I see now, Ella, you're answering my questions. I'm not going to change the bottom one. I'm going to leave it like it is. So I'm going to bring down the top one below it. So if I distribute the 3, I'm going to multiply 3 times x, which is 3x. 3 times 1y, which is +3y. And then 3 times 5 is 15. I'm ignoring that top one. I'm ignoring it. I'm just dealing with the bottom two. So I'm still combining my like terms. So 5x plus 3x is 8x. My y's eliminated themselves, gone. And 15 plus 17 is 32. So now when I divide by 8, x equals 4. Okie dokie. And then to get my y value, I'm going to plug in 4 in for x. So I'm going to go back to the top original problem because to me it looks so simple. X plus y equals 5. So if x is 4, to solve for y, I'm going to subtract 4 from both sides, and I see that y is equal to 1. So my answer is 4, 1. Okay? What is Naomi's trying to communicate with me, but I don't understand what you're typing. I'm assuming that you didn't mean to put that. All right, so what do you guys think? That's not too difficult, correct? All right, so let me give you one more to try, and then we'll have to have social studies because people are already in the waiting room. All right, let me find. All right, will you guys please try? Oh, they're all just multiplied by 2. I wanted to find a harder one than that. How about you guys try? Oh, well. Okay, do number 5. 5 is multiplied by a number other than 2. Everybody try. Can y'all see 5? It's a little blurry. Do we need to talk about it first, or y'all know what to do? We're good? Okay, I'll be quiet for a minute. All right, guys, so did any of you get to finish? I got -2, 0. Sorry, we're running out of time. All right. Oh, goodness. My keyboard is crazy sometimes. So, you could have, did I stop sharing? Can y'all see my PowerPoint still? Is it gone? You see it? Okay. So you could have multiplied the top by -7 to eliminate your x's. Or what I did is I multiplied the top by -3 to eliminate my y's. What did you guys do? Did you try to eliminate your x's or your y's? You did -3 for y, Helena? She did the same thing I did. Did you get to finish or did I rush you too fast? I was just fixing to start the second part of the equation. You had finished it. So what did you get what I got? I've already forgotten what I got. Was it -2, 0? -2, 0, I think. Yeah. All right, so I'm sorry we're running out of time, but everybody is waiting in social studies. It's going to be a very short social studies class, just so you know. Good, 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 good. Okay. All right, so I'm going to stop sharing and end the meeting. So my video will start recording, and then I'm going to open up the social studies class. Okay, so that was short and not so sweet, but we're done. All right, I'm going to end. So y'all stick around. I'll be right back.